Hi everyone, my name is Camelia Sherban and today I'm going to present you the paper towards a new test case prioritization approach based on fuzzy clustering analysis. The paper was written together with my colleague Andrea Vescan. So let's get started. This is our agenda for today. We'll start with some theoretical aspects regarding regression testing and test case prioritization problem, followed by our proposed solution. What does regression testing mean? Regression testing is conducted to provide the confidence that perform modifications to correct bugs did indeed correct them, and also to detect whether new errors have been introduced. It's obviously that running all the previous test cases is not feasible. Therefore, several approaches arise, like for instance, test case minimization, test case selection, test case prioritization, each one with its own benefits. In this paper, we approach test case prioritization problems, which means that we have to reorder the entire suite of test cases considering various criteria, like for instance, maximize faults while minimizing time execution. The existing TCP limitations refer to poor embodiment of the relation between requirements and tests and incomplete integration of the dependencies between requirements of the system under test. Therefore, our approach aims to overcome those limitations by proposing an augmentation of the TCP problem, incorporating requirements tests relation and requirements dependencies, along with class defect probability. This paper aims to propose a fuzzy clustering approach with various metrics serving as features for the considered test cases, considering several aspects: faults, execution time, requirements covered by the test case, requirements dependencies, and class defect probability for a test case. The reorder of the test cases will be formed based on the created cluster. Our approach will consider state-of-the-art criteria as faults and cost as matrix M1, M3. Also, we expand the criteria to three major perspectives. First, by considering requirements covered by the test cases as M4 metric and requirements that were changed as matrix M5. Second, the class defect probability as M7 metric, and third, considering test cases exercising the change by metric M6 that gives the highest priority to the test cases that directly verify the change requirements. A fuzzy divisive hierarchy clustering algorithm will be applied to you that use two measures. For a cluster K, we introduce the rank of cluster K that considers requirements and test cases for that cluster, and the weight of the cluster K that is computed by the fraction between number of test cases in cluster K and the total number of existing clusters. The algorithm produces a binary tree hierarchy. The reorder of the test cases is done by selecting the test cases from the clusters, considering the cluster's rank in descending order. From each cluster, the number of selected test cases being selected proportionally with the weight of the cluster. The process of selecting the test cases finishes when all the test cases are selected. We have proposed a fuzzy clustering approach for the TCP problem, having into account various state-of-the-art criteria and also new ones, considering requirements test relations, requirement dependencies, and class defect probability. Thank you for your attention. If you have questions, please feel free to ask me.